Nearly all terrain analysis is basically raster analysis, and is a pretty common form of raster analysis in GIS. So that's why I have a whole section just on this. Ultimately, all terrain analysis in GIS is based on a digital elevation model, or DEM, sometimes also called DEM, but I'll call it a DEM here. From this single DEM, which looks like this when we put it in a GIS, where each cell represents an elevation value, we can derive many other rasters, which then help us to analyze our terrain with GIS or display the terrain on a map. Slope is a fairly common terrain analysis tool where we use focal statistics. Remember our moving window? In this type of analysis, we analyze whether there is a change in slope between our center cell and the surrounding cells. The resulting output slope raster has cells where each represents a slope value, comparing that cell to its adjacent neighbors. In most GISs, there is a specific slope tool which uses focal statistics to do the following formula. I don't expect you to know this formula, but I do expect you to try to understand focal statistics so you could use this formula if you wanted to find the slope of a DEM by hand. The output from a slope operation is a raster that looks like this. The red areas here are very steep, while the green areas are flat. In the state of Oregon, you would see the red areas in our mountainous areas, while here in the Willamette Valley, we would mostly see green because we're relatively flat with the exception of a few bumps. Next up is Hillshade. Hillshade is somewhat complicated to understand until you see it, but it also uses focal statistics. In this case, there's a fake light source which you can place at any location. This light source is determined by the azimuth. That's the angular direction of the sun from north clockwise. So if you're going around in a circle, and the altitude. The default in most GIS software is 315 for the azimuth, which is northwest sun direction. This is somewhat random, but it looks nice, and we interpret maps with this sun direction correctly. And there's actually been a lot of perceptual research in my field on this. Altitude is the angle of illumination above the horizon. So think about this as what time of day it is. Is it noon when the sun is high in the sky and there are few shadows? Or is it late in the afternoon when the shadows are long? This is the output of a Hillshade function in GIS. Here, now we can see a really cool 3D looking version of our DEM. We can tell that there's a light source coming from the northwest, which allows us to see the rim and ridges of this crater. In this image, we've adjusted the altitude of the sun. In the top left, the sun is relatively high above the horizon. In the bottom right here, the sun is really low and close to the horizon. We can see different things about the terrain depending on how high in the sky the fake sun is on our terrain. Here we can't see a lot of detail, but here we might wash out a few too many things. Maybe something in the middle allows us to see some of those different ridges and terrain. In this image, we've adjusted the azimuth, or the direction of the sun shining, where the sun is shining from. 315 is the default in most GISs, but this can be adjusted. Often, if you change this too much, some people in the population start to see the image as inverted, meaning that valleys and canyons start to look like ridges and mountains, while mountains and ridges start to look like low valleys. I suggest generally leaving the defaults when using this tool, unless you plan to create a multi-dimensional hillshade, which is a bit beyond the scope of this class. Another common terrain analysis operation is aspect, which tells us which way our slope is facing. This is helpful for people who, say, study vegetation, because certain types of plant species only grow on slopes that face a certain direction. For instance, my whole front yard is moss, and I bet you can guess which direction my house faces too. Again, this tool uses focal statistics as well and gives you a pretty funky output. What it looks like is less interesting than what it allows you to do in your analysis. We can combine these different terrain raster data sets to create beautiful maps. Here, this elevation tinted hillshade combines a hillshade with a DEM that we've had like a color gradation on from almost white down through a brown into a lighter brown. You could also add things like aspect onto this, or even slope, to give your map a little bit different effect.